Hello, my name is Adam. So for this video, I want to walk through a recent blog post I posted on my blog, thecodinginterface.com, which describes how to create an AWS Elastic MapReduce, also known as EMR cluster, using the AWS CLI. So this video is mostly for folks that like to watch someone do something, as well as hear them talking through why certain commands or actions are being done, rather than just reading text on a screen type of thing. But I will definitely link at the bottom of this video back to the original blog post, so don't feel you need to scribble down and try to make notes for every single thing I'm doing. I don't intend to deviate really at all from this blog post. I just want to talk through it basically. So for those of you who might not know quite exactly what Amazon EMR is, it's a managed Hadoop kind of like cluster computing environment service that AWS provides. And really what all that means is it's just like a very easy and well-engineered way to create a cluster computing environment and configure it to have one of various different really popular open source cluster computing technologies like Apache Hive, Apache Spark, Apache Flink. There's honestly like dozens of them these days. So each of those are actually fairly complicated in their own right to install on top of a Hadoop cluster. So what they do is they allow you to just say, hey, I want Hive and I want Spark and I want this and that. And they have a whole slew of bootstrapping recipes that like the service will then go in and create and install on top of your Hadoop cluster for you. And that's fantastic. It really gives us as engineers the power to just provision something really quickly in the cloud, get in there, experiment with new tech, experiment with different workloads, and figure out, the right solution to whatever problem we're being faced with that day or that week, or, whatever our projects throw at us. So I love that aspect about both, cloud computing as well as just Amazon's EMR service in general, and I want to make sure I share it with the world. And then, the other thing worth mentioning is, like I said, I'm using the AWS CLI. Now, you can absolutely do everything I'm about to do in the AWS console, and I think that is awesome. But I also think that having a reproducible set of automatable commands that allow you to quickly reprovision the exact same environment over and over again is immensely important too. And there are other really great tools out there like Terraform, Hadoop, or Terraform, CloudFormation, AWS's new Cloud Development Kit that allow us to do that too. But they have their own little learning curves as well. So I just wanted to show the easiest way to do an automated provisioning, which for me is the AWS CLI. Maybe in a later video or blog post, I can show you how to do it with Terraform. I've done that a few times. It works really, really well. Obviously, AWS's CloudFormation works great for it too. Cloud Development Kit is pretty gnarly also. So just know that, we're using the AWS CLI right now for a reason, and that's just for reproducibility and automation. So without going any further, obviously since I'm using the AWS CLI and you want to follow along, you need the AWS CLI also. You can do that in your terminal and you can figure out what version you have. I'm using version 2, that's the latest major version. It should work with version 1 also. It's just I have the more recent one installed, which you probably should too if you don't. So the first thing I want to do is create an EC2 Key Pair so that I can SSH onto this Hadoop cluster as soon as I provision it and get on there and experiment with some things. So this command right here creates me an EC2 SSH key pair named EMR Key Pair, and then it writes it to a file here called EMR Key Pair.pem. So if I list my directory, we can see it's sitting right there. In order to SSH onto an EC2 instance, you have to restrict permissions a bit. So right now, this is at 644 permission style. So read write from user, read from group, and then read from anyone. They want you to have read only by the user. So that means chmodding to 400. And now if I list it, we can see it's only readable by the user. Okay, and the next thing I want to do, which isn't absolutely necessary for this specific tutorial, but it will be for upcoming ones, is just to create an EC2 bucket or an S3 bucket that I can put input data in, write output data to that gets processed in the EMR cluster, as well as store scripts and stuff that I might want to run in an automated fashion. So it's just kind of good to have an S3 bucket there, as well as to follow kind of a prescriptive layout of your bucket. So I'm creating specific folders, which I say in kind of like air quotes because there's no real thing such as like a folder in S3, but you can make it think it has folders, or it can make you think you have folders. So I'll have one for EMR logs, one for input data sets, one for writing output data sets to, and then like I said, one for holding scripts. So the next thing I want is I need to figure out what my home IP address is here, which Amazon actually provides a REST service that will spit back out your actual IP address, and I'll use that IP address actually to make a security group that's scoped specifically to my home, so that only like someone inside of my house could SSH onto any particular EC2 instance within my EMR Hadoop cluster. So what I'll do is I'll actually save this to a variable called my IP, and I'll run it in a subshell. And so, you know, like you could actually just put this part into your browser if you wanted to even, and get your IP address, but I'm going to save mine to a variable so that I can use it later. And then I also want my VPC ID to create a security group for this SSH security group that's specific to a specific VPC. And in order to do that, in order to SSH onto an EC2 instance of my Hadoop cluster, I need it to have a subnet that's publicly available. So for the last several years, every AWS account comes with what's known as a default VPC that has public subnets. So if you have just like a standard run-of-the-mill VPC or AWS account with a public with a default VPC, then you should have the ability to come in here and pick a subnet, and really all you're looking for is to make sure that you have a route to an internet gateway. So an anything route to the internet is how you know that you're dealing with a public subnet. So I'll grab my subnet ID there, and I'll save that to subnet ID, and then I want the VPC ID as well. So there's my VPC ID. All right. So now I'll run this AWS CLI command, which creates an EC2 security group. I'll name it my IP because I'm going to associate my specific IP address with it. That allows me to SSH from my home, and that gives me a security group ID back out. One more thing I have to do is create an ingress rule. So first I'll save that ID to a variable called mysg. And then if I run this command, it will create an ingress authorization for my specific security group that just got created here to allow TCP traffic inbound on port 22, which is the standard SSH port, to my IP address as a CIDR notation. So I'll run that. That should update the security group to allow that inbound traffic from my IP. The next thing that I'm not going to do, but because I've already done it essentially, is create a default EMR IAM role that gets associated with the EMR service, specifically the EC2 instances. Now, there is like a bit of a warning here. Like, these default roles are great because they allow you to quickly get up and going with EMR. So it allows you very like liberal access to many other services that you would commonly use, like obviously EC2 and S3, CloudWatch logs, you know, a whole slew of things. There's probably some ones in here for things like Kinesis, if I remember right, but basically it just allows you to get up and go quickly without having to fight IAM policies and stuff. However, that's great for like learning this and doing quick experimentation and development. When you go to production with your EMR clusters, you're going to want to scope those down to a much more reasonable span of other services that you're actually using, and not just having such wide open roles. So keep that in mind, please. And just, you know, if you want to follow along as I'm doing, create the default roles and use them. If not, read through the docs and determine the appropriate IAM roles for whatever you want to play with. Okay, one of the last things we got to do to actually create this thing is this gnarly long EMR create cluster command. And so I'm going to run it real quick first because it's going to take a little bit to spin up an EMR cluster. Usually it takes in between like 5 and 15 minutes. Let me run that. That gives me back a cluster ID. But I'm going to talk through over here what it does. So after create cluster, I'm giving it a name, TCI cluster, for the coding interface. I'm telling it it should install the following applications. So I want it to install Hadoop. I want it to install Hive. I want it to use the EMR version 5.33. I'm giving it this flag to say use the default roles that were created with this command. I want it to be a cluster of 3 instances. So specifically, it's going to have 1 master and then 2 worker core nodes. And all of the instances are going to be of type M5 extra large. So, you know, most people, myself included, don't remember every detail about EC2 cluster types. So let's go ahead and just look this up real quick. So M5 extra large has 4 CPUs, 16 gigabytes of memory, and let's actually talk price real quick too. Let's look at EMR pricing. So for me, I installed this to the US East North Virginia region. And if we see here, there's 2 components to the pricing. There's the EC2 price per hour, and then there's an added like EMR special sauce cost, I'll call it. And that's basically like the price that we pay for them to do the awesome DevOps stuff behind the scenes for us. So if we look here, it's roughly 20 cents an hour per EC2 instance. Remember, we have 3 EC2 instances, so let's just say that this is costing us in EC2 charges alone 60 cents per hour, US dollars. And then about 5 cents an hour per EC2 instance. I believe it's it's probably per EC2 instance per hour. So if we add 15 and 60, this is roughly 75 cents per hour that this thing is running, which which in the grand scheme of things is a little more expensive for AWS services in general. But if you think about what's going on here, this is a pretty awesome service to spin up such a very powerful cluster computing workload for us, with very little dev time, right? Like almost no engineering time went into running this simple command right here, and the ones that were preceding it. Whereas, if you were to spin up your own individual EC2 instances, install Hadoop, install HDFS, install Hive, you're going to be at this for a few hours until you automate it at least. And we're not cheap as software engineers. That's a pretty hefty price and amount of dev time and dev costs. So, 75 cents an hour to quickly spin these up and back down to do an experiment is pretty cool if you ask me. All right, so another thing worth calling out here is, there are dozens of different application types that you can have EMR install when you create your instance. Another really common one is Spark. So if you're after Spark, just add Spark to that line right here, and you'll have yourself a Spark instance up and going. And definitely check out the docs, because there are dozens, Hive, Hue, Pig, more than I can remember. And then, so like I said, it can take 5 to 15 minutes depending on the pool of warm and cold EMR clusters available out there. So what you'll want to do is you want to copy this cluster ID, and I'll make another variable for it, call cluster ID, and then you can use the describe cluster command to check the state of it. And so this is going to go through a couple different states. It's going to go through a starting state, and then it's going to go to a running state very briefly, and then it's going to go to a waiting state. We really can't do anything on it until it hits the waiting state, because that means it's then completed all of its installs. It's provisioned all the servers and installed all the application components on it for you. So don't really try to get in there and do anything until it hits the waiting state. But there is one important piece of information in that there is a field in that nested JSON output that comes out of the describe cluster command that gives you the public DNS name of your master node, which is where we'll want to SSH onto and submit our programs and experiment with the various applications that we've installed on top of Hadoop. So let me run this. And so I'm doing a compound statement here. One, I'm doing that describe command, describe cluster command with passing it the cluster ID, but I'm also using JQ, which is just a common JSON querying tool or parsing tool that's going to dig out the domain name of that, long, messy, nested thing here of the output of the describe command. And then I'll save that to master underscore URL variable name. So if I echo this out, there it is. So, depending on what state it's in. All right, so it's reached the waiting state. That's fantastic. That means we can get on there and start playing around. So let me just go ahead and echo out master URL again, and then I'll go ahead and SSH. So we're going to use that PEM key that we got earlier. So SSH as the Hadoop user at the domain for the master node, and give it my EMR key pair. Accept the fingerprint, and you're on there when you get this really cool text graphic that says EMR in front of it. And so now I can prove, that Hadoop at least is installed in the Hadoop file system by doing Hadoop fs ls, the user directory of the Hadoop file system, and you should see these kind of standard directories were created. And then I could also jump into the Hive program or jump into the Hive CLI to make sure Hive got installed properly, which I'm sure it did. Just taking a minute to start. And so now if I do show databases, we can see the default database is there. So that tells me that Hive got installed also. So I'll go ahead and exit out of that, and then I'll exit out of the EMR cluster itself. And then I'm back here, and last but not least, it's very important that we remember to terminate these because they do cost real money, and you know, 75 cents an hour isn't a ton of money usually to most people, but if you let this thing run for a weekend on accident, it'll add up. So make sure you run this command here to terminate the cluster. And honestly, that's about it. Please stay tuned for up and coming articles and videos where I dig more into, you know, how we can actually use EMR Hadoop clusters, why we might want to, and the type of problems that we can solve with them. So thank you very much for watching, and stay tuned for future videos. Bye.